As we explore the moon and we explore Mars, we move into terrains that we don't have a lot of experience with as human beings. We can actually use this robot as an instrument itself. It's not just carrying scientific instruments, it's producing data that allows us to understand what the planetary's material is, what it's made of. And that's also important in terms of if we're gonna walk on it, drive on it, build with it. We need to understand the mechanical properties of how this material deforms or sticks together.
Good morning, LASSIE team. Please be cognizant of the flags today where you're walking. Be safe, take care of each other and yourself. Thank you very much.
So LASSIE stands for Legged Autonomous Surface Science in Analog Environment. The project integrates technology to enhance future exploration of planetary surfaces.
We've explored lunar analog environments on Mount Hood in Oregon. Here, we're at White Sands National Park in New Mexico, which is a Mars analog.
There are sand dunes on many of the worlds in our solar system. And this terrain enables us to explore how robots behave in that particular environment.
NASA has a really exciting goal of putting astronauts on the surface of Mars, and there will be robots there working side by side with them. So really what we're doing out here is the first initial steps that would allow for smooth operations on Mars.
And when exploring with humans, there's a lot of complications and challenges. And the leg robots are excellent for scouting, just like dogs or horses are excellent for scouting. And so this is why we want to advance this technology for the future missions.
So Spirit is our quadrupedal robot that each of its legs can be used as a terrain sensor.
So when we are walking, you are taking your footing and understanding the forces that you're applying to the ground. So a walking robot does the same thing. Using that information, we can actually do science. So now we can look at that force feedback and say, this is softer terrain, this is harder terrain, this slips funny, this might be wet because it's cohesive. And all of that information just comes from the fact that we can feel the ground. And those are sensors that we're getting from the motors, just the current, the amount of force and torque that the motors are applying to the world around them, similar to how your muscles apply forces and torques to the world around you.
So we're developing this called sensing during locomotion capability for our leg robots, such that when we send them to the moon or the Mars, and they can report this data to our scientists.
This trip is a really interesting collaboration between the LASSIE project and the TRUSSES project. They have different but complementary goals. The TRUSSES project is really about expanding the capabilities of robots to be able to access environments that we've never been able to access before.
There are multiple modes we can use with a robot to explore a landscape. The traditional one is wheels because they're power efficient and you can carry heavy payloads. And so pretty much every rover that we've sent to another planetary body has been a wheeled rover. The thing with wheeled rovers is that they can cover long distances if the terrain is flat and firm enough, but they get stuck if the soil is loose, and they get stuck if slopes are steep.
What we imagine in the future is we'll have a group of legged robots running around and using their legs to feel where it might be soft sand pit that the rover might get entrapped. This information can be passed to the rover by the leg scout.
And so they can walk around and produce literally a map, but the map says in every spatial location, this is strong, this is weaker, this is very weak. And what we can do is look at that and say, hey, there seems to be a highway along here, a safe zone for both wheeled robots and humans to traverse. The question is, can we use wheeled robots for their strengths and use legged robots for their strengths? But then a wheeled rover gets stuck. Can a legged robot come over and get it unstuck?
Yes, I do. You should be able to hand tighten that.
And try to go up. If it gets stuck or if we need to reset it, have it go transverse. Yes.
The name TRUSSES pretty accurately describes the project. It's an acronym that stands for Temporarily Robots Unite to Surmount Sandy Entrapments, then Separate.
So the trusses part refers in particular to this telescoping truss to attach one robot to another robot when they need to, so that, for example, a legged robot can get a wheel robot out of a jam.
So we're hoping that by combining both, they can significantly extend our reach of the planetary surfaces that we can go and scout and take measurements.
And so if we're able to navigate the sorts of environments, perhaps getting these robots to work in tandem, this could be really useful for scientific exploration. It could be useful for construction of future habitats, but the robots need to be able to navigate these environments autonomously.
Robot autonomy is particularly beneficial when we consider that the communication between Mars and Earth is very limited. In current Mars operations, you have rovers on the surface of Mars communicating back to scientists on mission control on Earth. So here at White Sands, we've created our own version of mission control where our quadruped is communicating to our scientists.
Maybe the soil here is wetter, maybe it's more...
Thinking about what do the scientists back on Earth in mission control really need to know about what the robots have discovered in order to send instructions back to the astronauts and the robots on the surface of the other planet. So robots are going to be collecting data, but astronauts are also going to have a role in the data collection process. So here at White Sands, we're testing out instruments that the astronauts could potentially use to study and understand Mars alongside their robot teammates.
One of the really cool instruments that we are using here in this project is called LiDAR, and it's a LiDAR that's on a backpack. And what the LiDAR is able to provide us is a model of what the surface looks like. It was originally designed to explore how astronauts could be collecting LiDAR on the moon and other planetary bodies. And we can imagine that if an astronaut was wearing the LiDAR backpack and it was walking with its little robot dog, that they could be continuously collecting data together and, again, optimizing how we explore planetary environments.
And so I would love to see this optimum teaming where robots actually go out, tell us where it's safe and unsafe to go, and also where it's potentially most scientifically interesting to explore, so that we can use the very precious time of astronauts that are taking huge risks to go to these places most optimally.
So looking forward, we expect that from being humans' best friend on the Earth, the robot dogs, Spirit and its friends can support human exploration on the Moon and Mars and beyond.